Hi friends, welcome to follow up. Let's have a look at problem 863, all nodes distance key in binary tree. In this video, we're going to explain a solution based on breadth first search traversal, or breadth first based traversal. So here we are given the root of a binary tree and the value of a target node, and an integer. So we are required to return an array of values of all nodes that have a distance key from the target node. So if we look at the function signature, here target actually is a tree node, right? So here we should actually have a target node. So from the return, actually we can also see the values of the nodes are unique. So we can return the answer in any order. So here are two examples. In the second example, the output is an empty list. And in the first one, so the target node is with value 5. So the values to return is 1, 4, 7. So these three nodes, these three corresponding nodes have distance 2 to the target node 5. So with that said, let's also look at the constraints. The number of nodes in the tree is in the range given by the closed interval 1 and 500. So the node value is in this range 0 and 500, and all the values are unique as it should be due to the return format. So target is the value of one of the node in the tree. Actually, this is not precise here. From the function signature, target is a tree node. So here k is in between 0 and 1,000. So with that said, let's look at the coding part. So in between, we're going to explain the logic. So in this problem, the context is a binary tree. So however, if we want to compute distance, let's see, distance key nodes from the target node, it's not easy using the binary tree structure. The reason is that the binary tree is sort of directed because we have a parent, we have children, right? So here what we want to do and our strategy is to transform this tree into a general graph, and then we do breadth first based traversal. So because it involves distance, so breadth first based solution comes into play. So with that said, let's first do the coding, and in between, let's explain the logic. First, we build a graph. So notice that tree is a special graph. So it's a singly connected graph, and with n-1 edges, where n is the number of nodes, right? So here, let's build a graph. I'm going to use nodes and adjacency list. So here I'm using set as a representation. So now we are going to do a traversal so that we can establish the edges or connectivity. So here let's use depth first based traversal. So here this is the standard while loop for the traversal, right? So we'll get node equals s_pop. And then for the current node, we're going to check its subtrees or children. So if node left, so then we have edges from node to left or left to node left to node. So this means that graph. So we just need to use the value because the value is unique, right? So node value. So because this is a dictionary, so we're going to use add node left value. So this is the one direction. Now let's look at another direction. So node left value. So add node value. And this is one. And then we are going to do append, right? As append node left. So this is one part. In parallel, we are going to check the right subtree or right children of the current node. So let's copy this if block and then change this left to right. So let's change this to right. So similarly here. And also we have right. So here the order of these two if blocks are not essential for this process. Actually, if we want to do specific order of traversal, for example, pre-order traversal, so here we should put node red before, right? So that's the value known. So now let's look at the result. So prepare the return. So for this, I'm going to initialize a empty list, and then we want to do breadth first traversal, starting from the source target, right? So here, after we build the graph, so here in this graph we use value. We use an integer value as representing nodes, right? So now let's use queue. So it's collection. Collections. So here I'm using deck. So we start from target value, right? So then the distance of the target value with itself is 0, right? So in other words, in this tuple we have node value, I would say, and distance to the target. And then we are going to do the breadth first traversal. So let's use visited to avoid a repetition. So next is a standard traversal block. So basically we have a node. So notice that here this node represents an integer, right? All the node values in the above. So here we have node and dist equals q. So here pop left. Then if node not in visited, so what we are going to do, we first add this node to visited, and then we want to check if distance equals k. It means that the corresponding node in the original graph has a distance k from the target node, and then we are going to append the corresponding value to the result list. And then after this check, so we are going to do to check the neighbors for neighbor in graph node, and then if neighbor not in visited. So notice that we did twice of this check. That's just the first, maybe a repetition, but this will make sure the logic is correct. So here we are going to append neighbor and distance plus 1, right? So this is the, so notice that here in building the graph we used a traversal, and in finding the distance we used another traversal. So after this we just need to do the return. So we return the final state of this result variable. So now let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So here, this basically about it for this problem, but we want to give a last comment. So in this problem, it provides us an example that we transform a data structure, that is binary tree, to a general graph, and then this transformation makes solving the problem easier. So this is actually good to realize or notice. So with that said, that's about it for this video. Thank you.